Several circuit tracers are available that could meet requirements. These include the Fluke T5-1000 electrical tester, the Klein Tools ET450 circuit tracer, the Amprobe CT-450 circuit tracer, the Southwire 1400114 circuit tracer, and the Ideal Industries 61-271 circuit tracer. The Fluke T5-1000 electrical tester detects live circuits and neutral wires, features an open circuit indicator, and includes a non-contact voltage detection mode. The Klein Tools ET450 circuit tracer uses high-frequency inductive technology. It locates and identifies circuits on both energized and non-energized systems and features a built-in flashlight and receiver for easy tracing. The Amprobe CT-450 circuit tracer detects hot, neutral, and ground wires, offers both audible and visual indications, and includes a built-in voltage tester. The Southwire 1400114 circuit tracer uses digital signal processing technology for accurate tracing, features a long flexible probe and backlit display, and detects live circuits, open circuits, and shorts. The Ideal Industries 61-271 circuit tracer features a non-contact voltage detector, includes a built-in circuit breaker finder, and offers both visual and audible indications. To avoid false readings on breakers, firstly, ensure the circuit tracer is properly grounded. Secondly, use the tracer on a live circuit, as the induction signal can be inconsistent near breakers. Thirdly, move the tracer probe slowly and deliberately to get accurate readings. Fourthly, if you suspect a false reading, disconnect the circuit at the breaker and retest. When using a circuit tracer, understanding its technology is paramount. Circuit tracers primarily employ two methods: inductive tracing and direct connection tracing. Inductive tracing involves generating a signal with a transmitter and then using a receiver to detect that signal along the circuit. This method is particularly useful for tracing concealed wiring. Direct connection tracing requires physically connecting the transmitter to the circuit, which is generally more accurate, but also requires more caution and may necessitate energizing the circuit. Each circuit tracer model has its own set of features and limitations. Some models, like the Fluke T5-1000, focus on basic voltage and continuity testing, which can be helpful in preliminary circuit checks. Others, such as the Klein Tools ET450 and the Southwire 1400114, offer advanced signal processing and high-frequency technology to improve accuracy and reduce false readings. The Amprobe CT-450 stands out with its ability to detect hot, neutral, and ground wires, providing a comprehensive view of the circuit's condition. When evaluating a circuit tracer, consider the environment in which it will be used. For instance, a model with a long, flexible probe, like the Southwire 1400114, can be beneficial for reaching tight spaces and navigating complex wiring configurations. A backlit display is also essential for working in dimly lit areas. Models like the Ideal Industries 61-271, which include both visual and audible indicators, can be advantageous in noisy environments where visual cues might be missed. Understanding the principles of electrical circuits is crucial for effective circuit tracing. A basic understanding of voltage, current, and resistance can help in interpreting the tracer's readings and identifying potential issues. For example, if a tracer indicates a high resistance in a circuit, it could point to a loose connection or a damaged wire. Similarly, an unexpected voltage reading could indicate a short circuit or a ground fault. Proper grounding is paramount to avoid false readings. A circuit tracer relies on a stable ground reference to accurately detect the signal being transmitted. If the tracer is not properly grounded, the signal can become distorted, leading to inaccurate readings. Ensure that the ground clip of the tracer is securely connected to a known good ground, such as a grounded metal enclosure or a grounded electrode. When tracing circuits near breakers, be aware that the inductive signal can be inconsistent. This is because the breaker itself can act as a shield, attenuating the signal and making it difficult to trace the circuit accurately. To mitigate this issue, it is recommended to test the circuit on a live wire away from the breaker. This can provide a clearer signal and reduce the likelihood of false readings. Moving the tracer probe slowly and deliberately is another key technique for avoiding false readings. A rapid or erratic movement can cause the tracer to pick up stray signals or electrical noise, leading to inaccurate results. By moving the probe slowly and deliberately, you can ensure that it is only detecting the intended signal. If you suspect a false reading, take the time to disconnect the circuit at the breaker and retest it. This can help to eliminate any external factors that might be interfering with the tracer's accuracy. By disconnecting the circuit, you are isolating it from other potential sources of interference, such as nearby electrical equipment or wiring. In addition to these practical tips, it is also important to understand the limitations of circuit tracers. While these tools can be invaluable for troubleshooting electrical problems, they are not foolproof. They can be affected by a variety of factors, including the type of wiring, the presence of metal conduit, and the proximity of other electrical circuits. When using a circuit tracer, always exercise caution and follow all safety guidelines. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses, and be aware of the potential hazards associated with working with electricity. Never work on live circuits unless you are qualified to do so, and always de-energize the circuit if possible before beginning any work. Regularly inspect the circuit tracer for any signs of damage or wear. Damaged or worn components can compromise the tracer's accuracy and safety. Replace any damaged or worn components immediately to ensure that the tracer is functioning properly. Consider the different types of circuits you will be tracing. Some circuit tracers are better suited for certain types of circuits than others. For example, a tracer with a high-frequency signal may be more effective for tracing circuits in metal conduit, while a tracer with a low-frequency signal may be better for tracing circuits in residential wiring. Pay attention to the tracer's display and indicators. The display will typically show the signal strength and direction, while the indicators will provide visual or audible cues to help you locate the circuit. Learn how to interpret these readings and indicators accurately to avoid misinterpreting the results. Practice using the circuit tracer on known circuits before using it on unknown circuits. This will help you to familiarize yourself with the tracer's operation and to develop your troubleshooting skills. Start with simple circuits and gradually work your way up to more complex circuits. Keep the circuit tracer clean and dry. Moisture and dirt can interfere with the tracer's accuracy and performance. Clean the tracer regularly with a soft, dry cloth and store it in a dry place when not in use. Be aware of the potential for electromagnetic interference. Circuit tracers can be affected by electromagnetic interference from other electrical devices, such as computers, motors, and transformers. To minimize the effects of electromagnetic interference, keep the tracer away from these devices when possible. Refer to the circuit tracer's manual for specific instructions and troubleshooting tips. The manual will provide detailed information about the tracer's operation, features, and limitations. It will also offer troubleshooting tips for common problems. If you are unsure about how to use the circuit tracer or if you are experiencing problems, consult with a qualified electrician. A qualified electrician can provide expert guidance and assistance. Remember that circuit tracing is just one tool in the electrician's toolbox. It is important to use a variety of tools and techniques to diagnose and troubleshoot electrical problems effectively. Other tools that may be helpful include a multimeter, a clamp meter, and a wire tracer. Consider the tracer's portability and ease of use. A lightweight and easy-to-use tracer will be more convenient to carry around and use in the field. Look for a tracer with a comfortable grip and intuitive controls. Evaluate the tracer's battery life. A tracer with a long battery life will be more reliable and less likely to run out of power in the middle of a job. Look for a tracer that uses common battery types, such as alkaline or lithium-ion batteries. Check the tracer's warranty. A good warranty will protect you against defects in materials and workmanship. Look for a tracer with a warranty of at least 1 year. Consider the tracer's price. Circuit tracers can range in price from a few $100s to several $1,000s. Choose a tracer that meets your needs and budget. Remember to always prioritize safety when working with electricity. Follow all safety guidelines and use appropriate personal protective equipment. If you are not comfortable working with electricity, consult with a qualified electrician. When dealing with false readings, consider the possibility of ghost voltage. Ghost voltage is a small voltage that can appear on a wire even when the circuit is de-energized. This voltage is typically caused by capacitive coupling between adjacent wires. A circuit tracer can sometimes detect ghost voltage and misinterpret it as a live circuit. To avoid being misled by ghost voltage, use a multimeter to verify that the circuit is actually de-energized before working on it. Look for a circuit tracer that has a built-in filter to suppress ghost voltage. Some tracers have a filter that can be activated to reduce the effects of ghost voltage. This filter can help to improve the accuracy of the tracer in situations where ghost voltage is present. Consider the type of environment in which you will be using the circuit tracer. If you will be using the tracer in a harsh environment, such as a construction site or a factory, look for a tracer that is rugged and durable. A rugged tracer will be better able to withstand the rigors of the environment. If you will be using the tracer in a damp or wet environment, look for a tracer that is waterproof or water resistant. A waterproof tracer will protect you from electric shock and prevent damage to the tracer. If you will be using the tracer in an area with limited access, look for a tracer that is compact and lightweight. A compact tracer will be easier to maneuver in tight spaces. A lightweight tracer will be easier to carry around and use for extended periods of time. Consider the additional features that are available on some circuit tracers. Some tracers have additional features such as a built-in flashlight, a non-contact voltage detector, and a circuit breaker finder. These features can be helpful in certain situations. A built-in flashlight can be useful for working in dark areas. A non-contact voltage detector can be useful for detecting live wires without having to make direct contact. A circuit breaker finder can be useful for identifying the circuit breaker that controls a particular circuit. Regularly calibrate the circuit tracer. Calibration ensures that the tracer is providing accurate readings. The calibration interval will vary depending on the tracer and the manufacturer's recommendations. Follow the manufacturer's instructions for calibrating the tracer. Keep the circuit tracer's software up to date. Some tracers have software that can be updated to improve performance and add new features. Check the manufacturer's website for updates regularly. Consider the tracer's compatibility with other tools and equipment. If you use other tools and equipment that are compatible with the tracer, it can make your job easier. For example, if you use a multimeter that is compatible with the tracer, you can use the multimeter to verify the tracer's readings. Use the circuit tracer in accordance with the manufacturer's instructions. Failure to follow the manufacturer's instructions can damage the tracer or cause inaccurate readings. It is important to read and understand the manufacturer's instructions before using the tracer. Store the circuit tracer in a safe place. When the tracer is not in use, store it in a safe place where it will not be damaged or exposed to extreme temperatures or humidity. A good storage location is a toolbox or a storage cabinet.